Hello guys, today we do LeetCode question 101, symmetric tree. The question is, given the root of a binary tree, check whether it is a mirror of itself, i.e. symmetric around its center. So example 1 here, the root is 1. Root has a left child node of 2, a right child node of 2, so that's both symmetrical. 2 has a left child node of 3 and a right child node of 3. A left child node of 3 and a right child node of 4, and the right node has a left child node of 4 and a right child node of 3. So as you can see, it's symmetrical. They're both reflected. Here, example 2, 1 has a left child node, right child node of 2, so far symmetrical, but the left node has a right child node of 3, and the right node has a right child node of 3, so that's not symmetrical, as you can see. The way we'll do this is using depth first search and recursion. We'll create a function to check if the most outer nodes are the same and the most inner nodes are the same. This way you know that it reflects. And once it returns null, we return true. If the nodes don't match, we return false, and if one of the trees is null, we return false. Let me show you how we'll do it. So let's say we're given the root here, which is 1. So root is 1. We'll check the left side node and right side node with a function. So let's say right now we check the left node here. We know it's 2. We check the right node and it's 2. Now are the nodes the same? They are, so we proceed. We check that. Then we compare the leftmost node and the rightmost node. Are they the same? They are. We check the rightmost node and the leftmost node here. Are they the same? They are. Then we check here. Is that null? Yes, so return. We check the right. Is that null? Yes, so return true. Go the same here. Outmost node first. Is that null? Yes. Go left. Null? Yes. Return true. Go back down here again. Null. 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 So everything's the same. So we return true. But let's say, for example, we have a tree like this where this node does not exist. So we'll start by comparing first the child nodes here. Are they the same? Yes. So we go down to the furthermost nodes on the right, on the left, and the furthermost node on the right. Are they the same? Yes. We go left again, no. Right again, no. Check the inside, no, no. So they're the same. We continue, go back up. Then we check the innermost nodes. We have 4, and here it's null. So we have 1 null and we have 1 node. So we know they don't match. So then we return false. Let me show you how it's done in code. So first thing we do is create a function. So let's say isMirror, and we pass a left and a right value. Then we check if left is equal to null and right is equal to null. We know the values are the same, so we return true. True. Else, if left is equal to null or right is equal to null, so if only one of them is equal to null, then we know the values don't match, so we return false. False. Then we return true if left is equal to right, and isMirror. We have to check the furthermost left node with the furthermost right node. So sorry, left.left and right.right. If they both return true, and if the innermost nodes, so isMirror left.right and right.left. So if all of this returns true, then we return true. Else we return false. And then we call the function isMirror with root and root. That's both of them. That's the main root as left and right. So from here, we then check left, right. Are they both null? No. Is one null? No. Then we check left. Are the values the same? Yes. Then we proceed with isMirror left.left and isMirror right.right. So left is 3, right.right is 3. Are they the same? Yes. Then we check left.right is 4, right.left is 4. They're the same? Yes. Proceed. And as you can see, everything will return null and it will mirror. So let's return this. Return isMirror. Let's see if that passes. Wrong answer. 1, 2, 2, 3, 4, 4. Okay, I see. Here we have to return left.val, the value at left. If the values are the same, then it will return true. Not the nodes itself, because the nodes themselves won't be the same, but the values should be the same. Let's see if it passes. It does. Let's submit. Perfect. As you can see, this is one of the fastest methods, beats 100% of people. Time complexity is of O of n. I'll actually go through the whole tree. And the space complexity is also O of n, where n is the height of the tree, as we're going to store each value here and check it at each point. Thanks for watching.